Carrie Macarthur and I'm 9 years old. My project came about after I watched a documentary on the exploration of the Titanic. The remains of the wreck was too deep for human or submarine to get down that deep. Scientists decided that the only way to get down to the wreck was to use underwater ROVs. An underwater ROV, remotely operated vehicle, is an underwater vehicle that can take videos and pictures. It is also known as a tethered underwater vehicle. It is controlled by a person above water. I was immediately intrigued. How could something as simple as an underwater ROV get down that deep when specially made submarines couldn't? After researching more about underwater ROVs, I decided that my challenge was to build a working underwater ROV using easily sourced materials.
There are three main components to the ROV: the frame, structure, the thrusters and propulsion mechanisms, and the control box. My underwater ROV has three propellers, one for left and right and one for depth down. My switch box allows me to control each propeller separately and make them go forwards and backwards, up and down. I built the frame using PVC pipe. This was done so that there would be no water leakage and also to act as a flotation device. Building the frame itself was quite a complex matter, using T-pipes, specially sized PVC pipes, and 90-degree elbows. I first connected the power sources. I made sure that the correct polarity of the control box was connected to the correct side of the motor, positive to positive, negative to negative. The waterproofing of the motors was paramount. Before putting the motors in the holder, I covered them in electrical tape and sprayed them with waterproofing agent. I designed a specific waterproof holder for the motor and completely sealed this with silicone. The control box integrated a lot of complicated wiring. The wiring had to follow a specific design to allow the switches to correctly power the right motors. The wiring used was Cat5 computer cable, stripped open to use its internal wiring. This has the advantage of a thick shielding, which ensured that the wiring did not get wet when underwater. As I turn the propellers on, the power of the motors pushing the water back causes the underwater ROV to get propelled forwards. As I turn on the depth propeller, the motor on the top starts to make a whirlpool around that motor, and as the water is getting forced up, the underwater ROV is being pushed down. However, the deeper my underwater ROV goes, the more pressure is being put on it. To make the underwater ROV go forwards, I have to turn on both the right and left motors to even out the force being put on the motor. What you can see here is a video of me controlling my underwater ROV to venture and look at objects that I have hung or thrown into the water. What you are looking at is a video taken from the camera on the underwater ROV, being recorded underwater as I bring the ROV around the pool, and looking at the objects I have placed.
During this major challenge, I have learned about the force necessary to propel objects through water. I have also learned a lot about the history of underwater ROVs and an enormous amount about electronics. I participated in this challenge because I have a passion for science, and I wanted to challenge myself in different aspects. I believe that other girls should also participate in this challenge because it's a really fun challenge that gives you the chance to complete activities that makes you gasp, laugh, and most of all, get excited about science.